Alright, so we have talked about the different ways, the way of doing polynomial derivatives, and that's a big one, right? If you think of the equations we use in physics, delta x equals v initial t plus 1/2 at squared, these are all polynomials, so that's a good thing. But there are other functions that we need to know how to take the derivative of, one of which is the exponential function. So the exponential function, if my pen is working, is y is equal to, let's just make it simple, ex. So what is dy dx? Well, we need to find a function that gives the slope of this. Now, this Euler's number, I'm not an expert on this. I think I told you I'm a physics teacher, not a math teacher. But I do know a couple of interesting features. Number one, at this point 0, 1, the slope is 1. I don't know if you knew that, but that's a feature of Euler's number. And then at point 1, the function is e. So it turns out that if you think about it, out of this function, what's going to give me a value of 1 when x equals 0? Well, actually, it turns out to be the same function again. It turns out to be e to the x as well. Because think about it, e to the power of 0, anything to the power of 0 equals 1, right? And this continues on throughout. Now, there's a little caveat to this, and that caveat is, what if you have y is equal to e to the 2x? Well, when you take the derivative of that, it's a little bit different, but it's not too bad, because all we do, and I'm not going to tell you why, because I don't think I know why, but I mean, I can kind of think about why, but yeah, I'm not a math teacher. All you do is take that 2 out front, whatever the constant is out front, and then it will be 2 times e to the 2x. So one last one, y is equal to e to the, where you going? 2 pi x. Then dy over dx is going to equal 2 pi e to 2 pi x. So that is the exponential function. Alright, what about logarithmic functions? So what if we have y is equal to log of x? What is the slope of this? Now again, for reasons, I believe this is a, actually this should be ln, natural log of x. Then again, the same thing is true. That right there at point 0, 0.10, the slope is 1. And it turns out that the derivative here is just dy, for crying out loud, dy over dx is equal to 1 over x. 1 over x. This actually makes sense, because as x gets closer and closer and closer to 0, this number will get, as it gets closer to 0, this number will get bigger and bigger and bigger and bigger, yeah. And think about it, this is a crazy high slope here, it's almost infinitely big, right? And then as x goes off to infinity, then 1 over infinity is basically 0, the slope's going to get closer and closer to 0. And that is all you need to know about that. So there's the derivative of the natural log. Let me just check something and I'll be back. Yeah, so that's not too bad, is it? And the only other one we need to talk about is good old-fashioned trigonometry. So here's what I'm going to do. I'm going to just make a sine curve. I'm going to draw it. Oh, easy now. Okay, it's not going to be perfect, but you know what? That's okay. There we go. This is a function, let's say y is equal to sine of x. Let's just say that. Now, if you remember, we talked about oscillators in physics, and normally an oscillator starts at an extreme position, it's a cosine. But let's just say it's an oscillator that starts at 0. As you go up, what is the slope? Where is the slope going to be 0? Well, the slope's going to be 0 here, and it's going to be here. So whenever I take the derivative, I'm finding a function that gives me the slope as a function of whatever the x value is. So I know it has to be 0 right here, right, the derivative, and then it has to be a 0 right there. Now this is a big positive number. This is a big negative number. So it has to be negative at 2, it has to be positive at 0, and it has to be positive at 4, because again the slope is going up like that. So what do we end up with? Well, we end up with, long story short, a cosine curve, right? So dy dx is equal to cosine of x. Now there is a caveat to that. That's not quite as simple as it is. So I'm just going to give you the actual one over here. I'm just trying to show you the logic behind it. So where you have y is equal to sine, let's say there's a constant. Let's say there's let's make a number up, 2x. Let's say y is equal to sine 2x. When you take the derivative, that 2 goes up front. And basically what you do is you do what's called the chain rule, and I'm not going to go into that, but where you take the derivative of the whole thing, which is cosine of 2x, and then you take the derivative of the thing in the middle, so the derivative of 2x is just 2. So it becomes 2 cosine 2x, just like that. So let me just make that more general for you, and I'll give you the actual rule. It's nice and easy. Again, the chain rule is where you basically do the outside thing, then you do the inside thing, but don't worry about it. All you need to know is where y is equal to sine of, let's say, ax, a is a constant, then the derivative dy dx is equal to a sine of ax. That a goes out front. Now, what if we have a cosine function? Okay, so what if we now have a cosine function like we do here? In fact, let me draw this under here. Let's say we have y is equal to cosine of x. What's the derivative of a cosine function going to be? Well, let's just think about it. Again, it's got to be 0 here, right? And it's got to be 0 at 4. And actually, it's got to be 0 at 2, right? Because all of these is where the slope is equal to 0. You can see my little cursor making a horizontal line. So this is 0. This is 0. This is 0. I just realized I'm going to run off the screen here. I have got a negative slope here. I've got a positive slope here. I've got a negative slope here. So negative at 1 and 5. So it's negative here. It's negative here. And it's positive here. So what do I have? I have got a sine function, but actually it is a negative sine function, negative sine of x. Alright, so again, if we want to make a general rule here, the y of cosine of ax, the derivative of cosine of ax is going to be the same thing where you do the chain rule, you take the derivative of the cosine ax, then you take the derivative of the ax, but you're going to end up with negative a, because the a goes out front. It's negative because this sign is upside down. Sine of ax, and there we have it. So I got a couple of little jobbies for you. I feel like that's really not enough, but it's fairly easy to do. So let's just go ahead and say y equals cosine. Oh, for crying out loud! Let's do y equals e to the ax. The derivative dy over dx equals ae to the ax. Let's do, these are just the general rules, right? Y is equal to ln of ax. A again is your constant. Actually, the a just kind of disappears, and it just becomes 1 over x. Y is equal to the, let's do sine first. Sine of ax, this becomes dy, the derivative of dy dx is equal to a sine of ax. Oh, wait, that's a lie. Complete and utter lie. Cosine. Because if it's sine, it's cosine. And then y is equal to the cosine of ax. Then dy dx is equal to, the a goes out front. It is a sine because it's a cosine, but it is negative. So it's negative a sine. So have a stab at all of these questions and show me your answers. See how you get on. Good luck, bonne chance, bonne suerte, bil glück, success. Bye, ciao.